Hey man, let's start in a couple of minutes.
Yeah, I have a question.
Yeah,
Um, I tried downloading the VM, but I wasn't able
yeah.
to find what's it called? I wasn't able to find the IP uh, using the app scan dash local.
Oh yeah, so the same thing that was happening to me, right?
Right.
So just do that thing. Just change the network type from uh, I think it was in, wait, let me share my screen.
I put it on bridge adapter.
Yeah, after you put it on the bridge adapter, restart it.
It's working, but I'm not able to find what what's it called? The Oracle virtual machine to know what the IP is.
Okay. In the list of ArcScan, none of them is the Oracle, the node
Yeah, let me just
itself
share
that you
my
require.
screen. Hold on.
Sure, sure.
I'll have to. Oh, let me, yeah. I'll be right back. Let me enter my password.
Sure.
Hi,
Hi, man.
yes, how you doing?
I'm well. What about you?
Good.
All right. Uh, see, I can find it. Can you see my screen?
Yeah, yeah. It will probably not show as VirtualBox.
You won't show as
Just
VirtualBox?
it probably won't. Only in VMware it shows as VMware, but in for VirtualBox it won't show like that. So what you can do is you can just take the ones that are unknown,
Oh no.
like
Okay.
68 and 82 and 222. Probably one of these are is the CTF.
Okay. I'll have to try that and see.
I can just nmap one of these. Right. So today we are going to learn something very important in cybersecurity, and I think This is definitely the most important topic according to me. All right. So I'll just share my screen. All right. So we're going to learn buffer overflow today. Okay. So okay. So this is a vulnerability in C programs. All right. C programs and C++ programs. Okay. So in programming, we have a topic which is known as data structures. It's basically how we arrange or store data, right? So we have different structures like array. Uh, one of them is known as structure also. And what heap, stack. Okay, these are some of the most common. We have tree also. Okay, these are some of the most common data structures. Okay, and we have already gone through stack, right? Okay, we know what a stack is. Okay, and stack uses for last in first out. All right. So in buffer overflow, we have a concept known as smashing the stack. Okay, and this is the reason buffer overflow occurs. Okay, so when smashing the stack, when we smash the stack, it causes segmentation fault. Okay, it causes segmentation fault. All right. Then again, in C programs, we have another concept which is known as pointers. Okay, there are two types: reference pointer and address pointer. Okay, so if you want to learn like very specifically how to implement this, just have a look at some programming videos. You will find it in U Boston, I think. Okay, you'll definitely find it. So address pointer is basically it finds the address. Reference is oh yeah, sorry, address pointer is the percent. Okay, and reference pointer, which is used a lot. We have already used reference pointer, right? Both of these we have used percentage D and N. Okay, so then we have stack pointers. Okay, and in stack pointers, we have again we have gone through all these. I think we have BP, which is base pointers. Okay, SP, which is stack pointers. Finally, we have IP. Okay, remember we did EIP, IP, that thing. Okay, and this is known as instruction pointer. All right, so we know what each does, right? Base pointer points at the base. okay, at the start of a pointer of a stack, okay, then SP, it points at the top of the stack, okay, at the last. Instruction pointer points to the next instruction that has to be executed. All right. So
So
if we
base
just,
pointer is at the ground level.
sorry,
The base pointer is at the ground level.
wait a second. I'll show you.
All right.
So let's say that this is a stack, okay, and this is the first item that we are storing in the stack, okay. Let's take that here we have added a text, okay. So this right here is the base pointer, okay. Okay, right here we'll have the what? Base pointer. All right. This is the base pointer. Okay. And then if we have more and more data inside the stack, okay. All right. So this one is going to be what? The stack pointer. Okay. So this is known as the different pointers in stack. Okay. All right. So this is an example of stack. All right. So let's take a look at a memory. All right. How things are stored inside the memory. All right. So at the top, we have the kernel. Right. Because obviously, in any machine, the kernel is always running in the RAM. All right. Then we have the stack. Okay. So this is the stack. All right. So let's say if we are storing some data, right? Let's say we are storing the word, uh, any word, for example, we are storing the word text, for example. So if this is the word that we are storing, so it will be stored like this. Okay, this is how it will be stored in the stack. Why? Why is it stored like this? Hmm?
To be able to have more space
No,
in the stack.
because LIFO. Okay, because
Last
last
in,
in,
first
first
out.
out. Okay. Then we have some whatever empty spaces there in the memory, we'll have it right here. Okay. And then we'll have another data structure which is known as heap.
So the text is gonna be the first thing out of the stack.
Whatever stack is going to be here, whatever the stacks are there that are to be stored is going to be here inside the stack. Okay.
Okay.
So this one comes like that, and this all the heaps. Okay. Heap is also another data structure. So it goes up. Okay. So this is the empty space and heap will go up, stack will come down. All right. Then we'll have another part here and it contains some data. All right. So whatever variables that we declare in a C program, int A, int B, all right, all that is stored here. And the program itself is stored right here. All right. So this is a memory. Okay. This is a what? This is a memory. Okay. So now what I'm going to do is I'll drop this. Okay. I'm just going to drop it like this. Okay. So that it will become kind of, how do I, is it possible to somehow arrange, align, rotate by 90-degree? Okay, this is what I'm saying. Okay, I'll make it like this. All right. Okay, I'm going to drop it, and then I'm really going to zoom really hard inside the stack. Okay, I'll just zoom very fast and very hard inside here. Okay, so that this here is the stack. Okay, so this is the stack. All right. Okay, this is the stack that we have. All right. So if we just take all this a bit further away, so around here, so since we have dropped this is going to be the empty space, right? This is this. Okay. See, this here will be clearer. Okay.
Sure. What did we drop? The stack?
What?
Or
We're
what
just
did we
changing
just
the
drop?
diagram a little.
No, you said something about dropping something.
Yeah, that's what I'm saying. I have just changed the diagram so that we can
Okay.
look inside the stack a bit properly. All right.
All right.
This is the empty space here, right? This
All
is
right.
the empty space here. Okay. And then if we take another one of these, okay, and this is going to be the kernel, right? Since we have dropped this, okay, if this is the stack, this is going to be the kernel, right? Okay. Okay. Are you able to get this? It's very simple, right? That's what I have done nothing. I'm just zooming here and I'm just looking at it vertically. That's all I'm doing. Okay. So this is the kernel. So this part became this and this part became this. That's all. Okay. Now we'll have at first the buffer. Okay. This area is known as the buffer. All right. Then we'll have, so guys, this diagram is extremely important. Okay. So you need to understand it very clearly. Then we have something which is known as EBP. Okay. Actually, or BP. Okay. So do we remember what this is? Base pointer, right? Okay. So this is the base pointer and it's pointing at the what? Start of the stack. All right. Then we have the instruction pointer. Okay. We have the what? Instruction pointer. All right. And this is also called return. Okay. And some other parts of the stack. Okay, these are just some other part specifically we just named as okay. So these are some other parts of the pointer, like we call it as Okay, we call them SBA. Okay, so it's not important right now. Okay, so what's happening here is whenever we allocate, remember we had malloc. Okay, did we learn about malloc? We did, right?
Yes.
Memory
Yes.
allocation. Okay,
Yeah.
so or like whenever we have some data, okay, that we are going to store. Okay, so it's created here. All right, it's created here. So this is how a stack is in a program. All right, so
Okay.
this is all that we need right now. Just remember that this is the instruction pointer. Okay, just remember that. Okay, this is the instruction pointer, and this is what we're going to be playing with. Okay, so I'll just show you one thing. Let's say that we have a buffer of size 10. Okay, let's say that we have allocated a memory of size 10. Okay, so it's go that that size is going to be exactly this much, right? That's why the stack will be like this. Like the moment we allocate some memory, just imagine this text. Okay, even though I have written it kind of just as a way to understand how it's stored, but actually this is how it's stored. Okay, so the text will be here, text. That's how it's going to be here. If I have, let's say, allocated a 10, all right, let's say 12. Okay, let's say I have allocated 12 letters. All right, so if I type my name now, I won't be able to store that much, right? Okay, let's say I have allocated 12. Okay, so I'll be able to store in the stack 12 letters. Okay, are you able to get this?
So we're storing data in the buffer.
Yeah, so whenever we we want to store a string, okay, we in C programming, one of the ways to do is, car uh, text, or let's say buffer. This is just a variable, all right, don't confuse it with the thing, or in this case 12. So now I can store the data, right?
Right.
Okay, this is how. So whenever we do this, so this is just a variable. Okay, okay, so whenever we do this, it becomes this, right? Okay, this entire memory is allocated, this entire stack is allocated, and it will have a base pointer and everything, and this is the data. Okay, this is the data, or this is at least this is the space where we will be storing the data. Okay, so this is all that is happening here. Okay, so now what I'm going to do is, so what you can do is maybe you can take a screenshot of this. Because we'll need this. So the way it is, take a screenshot of this. Done,
Yes.
both of you, Rajashree?
Yes, sir.
Okay, perfect. So now what we're going to do is we're going to write a program. All right, and it's going to be a very simple program. So obviously hash hash include. So do tell me at which part you don't understand. stdio.h. Okay, and also let's use hash include stdlib.h because we'll be requiring that, and let's also include as string.h. All right, we'll be using string.h also because we'll be doing some things with strings. All right, so now int main, and let's also do the argc int argc comma character star argv. We already know this, right? Okay, we are taking the arguments from the command line. All right, and let's just int a equals 0. Let's ignore this for now and print the you are in the main function now. Okay, and then let's create an overflow function. Okay, so int, this is just the name. Okay, we are just naming it. It's just the name, nothing else. Int overflow, and inside the overflow function, what I'm going to do is I'm going to enter the argument that is entered. Okay, so this is the argument that we entered in the command line. So I'm going to pass the argument to here. Okay, so obviously I have to now receive it. So character star as we are making it a pointer. Okay, and let's do one thing. Let's copy the data here and put it in a variable like so. Okay, actually what I have done is just return it here. Okay, let's call it buffer.c. All right, you can name it anything. So we have the overflow and character. Again, we are going to do this now. Okay, character buffer, and I'll just put 10 here for the time being. Okay, so that it's kind of easy for us to calculate stuff. So this is going to be the buffer. All right, and then strcpy. Okay, buffer comma s. Okay, we are not doing anything here. the only thing that we are doing is whatever we entered with the argument, we are copying it into the buffer that we have. Okay, that's all we're doing. We're copying the data that we have into the buffer. All right, and then return 0. Okay, so now let's also create another function. Okay, void exploit. Okay, and print f you are in the exploit function. Work. Okay, so again, this is just a function that is printing a line, and this is the line. Okay, finally what we're going to do is we'll have a conditional loop here. If a equals 1, okay, if a is equals to 1, then we'll run the exploit function, else printf buffer failed. Okay, and then finally, since again int main is being used here, so return 0. It's a very simple program, right? You have understood this. Okay, so just tell me what's going to happen here. What's going to be the result whenever we start the program? What's going to happen? Give it a try.
Uh,
What's going to happen? Just give it a try. It's fine. It's okay if you're wrong. This is the first time you're learning it. So in the program, okay,
Let me see what the exploit function.
basically this is the program. All right, I'll just zoom out a little so that you can see the entire program. Okay, so this is the entire program. Just tell me what is this entire thing we have already covered in class. Okay, whatever is there inside the program, there is nothing here that we haven't gone through before. All right, this again, in case you are confused about this, we are storing a string here. All right, we are storing a string here, that's all. Okay, for example, my name, we are storing here. All right, that's all we're doing. Give it a try. I really want an answer from either of you. Both of you would be really good. It really does not have to be right.
Is equals to 1.
I could not hear. Can you repeat that?
Oh no, I'm still looking at the code.
Yeah. When you look at code always start from main. Okay, when you look at C code, always start from the main.
When is the program not going to, is it not going to fail?
How? What's going to fail?
The exploits?
There is no exploit here.
I mean, the exploit function.
Yeah, it's not going to run, right? So what's going to
Yes,
be the result?
it will be buffer overflow field.
At first, this is going to be printed and this is going to be printed, right?
Right.
Okay, so let's look at that in action. So this is the program. Okay, I'm going to compile it and make sure that it's 32-bit. Then I'm going to, we have our program here, this one.
The required character string is 10, right?
This one.
Yeah.
Yeah.
And so that's how much we can enter up
Yeah,
to
that's how
up to
much
that.
data we can enter. Okay.
Okay.
So now, again, this is a buffer.exe. So buffer.exe and then space, we can enter the data here. Okay. So up to what? 10?
Yeah,
Up to
10.
10 we can enter, right?
Right.
So let's try with 10. And I'm in the main function, buffer overflow has failed.
Yeah.
Okay, so I guess I forgot to put the /n. So I'll just put it here as well. It looks a bit cleaner, nothing else. Okay, so again, if we do this, see, I'm in the main function, buffer overflow has failed. Okay, this is what was expected.
I'm confused.
Right.
Is it not supposed to fail if we enter more than 10?
Why?
Or am I not reading the program well?
There is nothing about more than 10 or less than 10 in the program. Just have a look at it. I'll just go through it once more. Okay.
Okay.
Int main. So we are just declaring a
Variable.
variable,
Right.
okay, as integer, putting a value of 0 in it. Okay.
Right.
And printf, you are in the main function. Then we have an overflow function, and it literally has nothing to do with the rest of the code. Okay, just have a look at it. We are just whatever we entered. In this case, we are entering 10 A's, right?
Right.
Okay. The 10 A's that we have entered will come to the overflow function here and will declare a buffer of 10. So to a character array. This is a character array. Okay.
Okay.
Okay. So inside the array, we are storing the what? So this is known as an array. All right. This is exactly what an array is. All right. Okay, but in this case, I guess this will be a stack of sorts. Okay, this is an array. Let's just consider this an array. Okay. And then we are copying this string of letters. Okay. 10 letters inside this. That's all we're doing, right?
Right.
We are just copying. It has nothing to do with the rest of the program. And then if a equals to 1, we'll run the exploit function. Else, if a is not equal to 1, then we'll print what? Buffer overflow has failed.
Okay, I understand what you're saying now.
Okay. As expected, the program worked exactly as expected for us. Okay, it has nothing to do with how many we have entered.
Right.
Okay, and so tell me under which condition with the same program can we run this exploit function? There is no way, right? There is
Right.
no way unless we change the program a little. There is just no freaking way that we can run the exploit function, right? Okay, we're just calling it an exploit function. There is nothing what exploiting here. Okay, it's just a printer, but we're just calling it the exploit function so that it's easier to understand a bit later. Okay, so there is no way because a is 1 and it has no chance of becoming a 0 no matter what. Okay, as long as the program remains the same, which is yes going to be the case, right?
Right.
So the question is, what happens if we enter 12 letters here? What will happen if instead of 10 we give 11 characters?
I think the program attempts to write more data to a fixed length.
Okay, good. Let's try. See, no error,
Okay.
right? No error. Let's try to put 12. No error, even now.
Then this can be used as exploit.
Yeah. See, even now, no error.
Okay.
Okay, let's try a few more. No error even now. I think we have put 16 till now. Now there is going to be an error. When we put 19, and the stupid thing about Windows is it's even showing us everything. Okay, it has given us like all the data that we normally use a reverse engineering tool like OllyDBZ for. All right. So this is something that we require. Okay. So just have a look at this. Okay. Exception, not this one, sorry, this one. Exception offset. Okay. We'll close the program and now we'll put many like 40. I'll click on enter and then again program details and see last time it was something 01F or something like that, but now it's 41, 41, 41, 41. Okay. So what's the 41? Do you know what the exception offset is? This is the instruction that was not running. Okay. This is the instruction that was not running. And do you know what 41 is? 41 is the ASCII character for A. Okay, there is ASCII character for everything, right?
Right.
For A, it's 41. For B, it's 42. Okay, and I'll prove it to you even. All right. So the instruction that did not run is exception offset. Okay. The keyword here is instruction. Instruction. Okay. That means this overflowed until it reached here. Okay. That's what happened. All right. Let me just. See, this is what happened.
So it took
Until here,
more than it's allowed to take.
yeah, it took more than it's allowed to take. That's not what exactly happened. See, if we had directly put the data here, then it had been different. But strcpy, it is a vulnerable function. Okay, strcpy is something that you should never use in your C program.
A string copy, right?
Yeah. So this is something that you should never use in your C program because it does not look at this. It will just start copying and only stop when everything is copied. Okay, because of which strcpy started copying into the buffer. It started copying here and then saw that there was more to copy and it kept copying. And in fact, actually it goes on copying. All right, this goes on and on.
Then they're not going to be to denial of service or something.
Sorry.
That's going to lead to denial of service.
No. That's a completely different thing. Completely unrelated to here. Okay, just forget that you said that. All right, but this is what happened, and whatever the instruction pointer was, all right, in this case it probably was return 0, right? It was probably return 0, the next instruction that is to be executed after this. All right, so that was the pointer, so it was probably pointing to return 0, but that was overwritten by string copy. And instead of that, whatever we entered here, in this case B, or in the previous case A, it will change it with A's. Okay, here we have shown as, but that's what was happening. Okay, so this is not some almost play toys like hacking some website. This is real. This is, we are actually directly hacking stuff inside the RAM at this point.
So,
Okay, this is as real as it gets.
so why does the string copy still exist then?
It just exists. Many things like this do still exist.
No, I'm talking about the function. If it's vulnerable to buffer overflow, why
Yeah,
would it still exist in the program?
it's just there. There are many things which are vulnerable, which are still there, right? So the thing is, it once it was made, like the vulnerability was not found out for 30 years or so.
Wow,
Okay, that's why.
that's a long time not to
That's a
find.
really long time because C programming started like ages ago. Okay, like in 1960s it started, and buffer overflow and all of these vulnerabilities people figured out much later. Okay, so this is known as buffer overflow. We have actually done buffer overflow. Okay, this is probably not even there in the course, but I really wanted to show you this because it's like I think that one should not call themselves a hacker unless they know buffer overflow, because being able to hack a website is nothing compared to knowing how all of the memory and all of this stuff work. All right, that stuff is also important, but this is the most important. This is definitely thing, and this is definitely something that you need to understand. Okay, so this is a kind of memory exploit which is exploiting C programs.
Does it
All
only
right,
happen with a C program?
mostly with C and C++. Okay, because they are the ones which you directly store inside stacks mostly. So, and also C program is the one of the only programs which can actually directly access memory due to pointers. Okay, we can directly access the memory using pointers, which other programming languages like Python and Java just cannot do. All right, they are not powerful enough. C is very powerful, because of which C programs are, and all of the operating systems are built using C. And that is why we have so many viruses and stuff. Okay,
Also, C is
so
comparatively faster than Python.
I think C is actually much faster than Python because
Yeah.
Python is an interpreted language. So interpreted languages are always slower than, because Python is obviously it's getting uh, you know first it's interpreted and then it's running. But whenever we have a C program, we compile it and then we run the binary instead of directly from the program.
Oh,
Okay,
okay.
so compiled programs are always faster.
Okay.
Java is kind of compiled and interpreted, so it's doing both. So Java is kind of a bit different, but C language, C is actually yeah, it's more powerful. Okay, performance, yeah, maybe in under certain circumstances performance is going to be better in Python probably. Okay, but when it comes to how much powerful, C is obviously powerful. You cannot build an operating system using Python, but Linux, all of these operating systems are mostly built with C only. Okay, so C and C++ programs contain these vulnerabilities, and it's known as buffer overflow. All right,
Well,
so just go through what I have taught. There is some more parts. Okay, just try to run this. Okay, I hope I have given you the correct program. Uh, Maybe there is some spelling problem or something that might be there, but I think I have done it correctly. So just if there is a small error, just correct it, all right? If I have left some semicolon or something, but I've mostly done it correctly as far as I can see. Actually, without running a program, you can never know. Okay, so this one I haven't run, but I have only run the other one. Okay, do try this one. All right. And Windows is just, it used to be so stupid because it just showed us like this is something that should never be shown. They rectified it in Windows 10. Okay, it doesn't work in Windows 10. It won't show you the exception offset anymore in Windows 10. We'll have to use a reverse engineering tool. But yeah, this is about it. Okay, so do try this in the next session. In the next 3 or 4 sessions, we are going to have buffer overflow only. Okay.
Okay.
Because this is how, like, if I give you one example of buffer overflow, I have a very simple one. Every time we do privilege escalation,
Privilege escalation.
okay,
Yeah.
or whenever we are doing metasploit connection, especially when we are doing privilege escalation, actually, we are actually doing buffer overflow. Okay, we're actually doing buffer overflow whenever we're doing, but we just don't know because we just directly use a ready-made program, right?
Right.
Okay. Exploit DB. Sorry. For example, the other day we did some Ubuntu 16.04 exploit, right? And it had a huge C program that we compiled.
Yeah.
Remember that C program? It was doing buffer overflow. Okay. So this topic again is very, very, very important. Okay. So just go through what we have learned today, and let's just finish it up in the next session. Okay. So thank you so much, guys.
All
See
right.
you on Monday.
All right. Bye. Thank you.
Thank you.
Welcome. Bye bye.